Hello students, I am Harshala Datte, Senior Lecturer of Department of Computer Engineering. In this video lecture, we are going to start the topic Substitution and Transposition technique. In previous video lecture, we have seen that there are two types of cryptographic technique, symmetric and asymmetric, whereas again symmetric has the two types, classic and modern, and classic has the two again types, substitution and transposition technique. So in this video lecture we are going to see that the classic techniques, cryptographic techniques. The unit outcomes of this video lecture are: after learning this, you will encrypt and decrypt the given text using any substitution technique. Also you can convert the plain text to ciphertext and vice versa using given transposition technique. The learning outcomes are: substitution techniques, that is scissor cipher and modified scissor cipher; transposition techniques, Ralph techniques and simple columnar transposition. So let us see both techniques one by one. Classical symmetric key cryptography. A substitution technique is a classical encryption technique where characters present in the original message are replaced by the other character or number or symbol. So in substitution technique, what we are going to do, we are going to replace all the character in the plain text by another character to form the ciphertext. So let us see the first algorithm, scissor cipher. It is proposed by Julius Caesar. It is one of the simplest and the most widely known encryption technique. In this, it is a type of substitution technique in which each letter in a plain text is replaced by the alphabet 3 places down the line. Means 3 places down the line means what? If your plain text has a character A, so 3 places down means what? After A, that is B, C, so D. So A will be replaced by the D, B will be replaced by the E, C will be replaced by the F, and so on. You can see the table, that is X can be replaced by the A because W is replaced by the Z. So after X, we are going to count like this: X, Y, Z, A. So X is replaced by A, Y is replaced by B, and Z is replaced by C. So all the plain text character A to Z are replaced by the D to C. For example, with a shift of 3, A would be replaced by B, B with E, and so on. So now we are going to see how this plain text is converted to ciphertext using scissor cipher. So there is a question: convert the plain text computer using scissor cipher. So plain text is COMPUTER. So in below table you can see that C is replaced by, you see the row of the plain text C and see the below ciphertext letter, that is C is replaced by what? F. So C is replaced by F. Similarly O is replaced by R, M is replaced by P, P is replaced by S, U is replaced by X, T is replaced by W, E is replaced by H, and R is replaced by U. So ciphertext will be FRPSXWHU. You can observe that since this is the substitution technique, all the characters in the ciphertext are different from all the character of the plain text. But since there is a fixed shift key in scissor cipher, that is 3, anyone can easily attack on it and get the original text. So there is some modification in the scissor cipher algorithm, that as we have the all 26 characters A to Z, so we can have the shift value 1 to 25. In scissor cipher we always take fixed shift value, that is 3, means what? A is always replaced by the D. But in modified scissor cipher you can take any shift value from 1 to 25. So you can take any 1, 2, 3, 4. For example, if you take the 1 as a shift value, then A will be replaced by B, B will be replaced by C. If you take 2 as a shift value, then A will be replaced by C, B will be replaced by D, and so on. So here let us see the question on the modified scissor cipher. Convert the plaintext computer using modified scissor cipher with the shift key 4. In modified scissor cipher, shift key is shift key is always present, always given by the always stated by the programmer, or always given by the paper setter in your examination. So here shift key is 4. So C is replaced. You can see that plaintext is computer, COMPUTER. So C is replaced by the 4 keys down. So C, after C, D, E, F. So G. So fourth character is G. So C is replaced by G. O is replaced by S. M with Q. P with T. U with Y. T with X. E with I. R with V. We are going to solve many problems in our live session for practice. In modified scissor cipher, the original plaintext alphabet may not necessarily be 3 places down the line, but instead can be any places down the line. That I have explained that A can be replaced by D in scissor cipher, but in modified scissor cipher A can be replaced by E, F, G, whatever, and so on. Let us see the second type, that is transposition technique. In transposition technique, if you remember in last video lecture, I have told you that in substitution technique we are going to replace each and every character of plain text by another character to generate the ciphertext. But in transposition technique, we are not going to substitute any character by the another character. We are just going to change the position of the character in the plain text. So in transposition technique, it is a technique that converts the plain text to ciphertext by performing permutation. So changing the position is also known as the permutation. You have to keep this term in your mind. Permutation is nothing but the transposition, because we are going to use this term in DES algorithm that I am going to cover in the next video lecture. So in transposition technique, PT is converted to CT by performing permutation on plain text, that is changing the position of each character of the plain text for each round. So let us see two algorithms of this transposition technique: rail fence technique and simple columnar transposition. So rail fence name is actually come from the railway tracks. So you can see that it is one of the easiest transposition technique to create a ciphertext. What are the algorithm steps? There are only two steps. First is write down the plain text as a sequence of diagonals. See, here is hello world is a plain text. It is with the depth of 3. So 3 rows are here. So with the depth of 3, your plain text is written as a sequence of diagonal. HELLO hello world. WORLD. Okay. And in step 2, we write it as a sequence of the row. So in first row there is a HOR, then EIOI, then ELOL, then LWD. So this is what your encrypted message, that is your plain text, ciphertext of the plain text hello world. So output is HORELOLLWD. We are going to practice some on this technique in our live lecture. This is one more example with the depth of 2. In previous example there was the depth of 3, here there is a depth 2. So convert plaintext MyBSCIT into ciphertext using rail fence technique with rail depth 2. See, plaintext is MyBSCIT. In step 1 we have write down the MyBSCIT as a sequence of rail diagonals MYBSCIT, and write in step 2 we read it row by row. So MBCTYSI. This is your ciphertext. The next algorithm of the transposition is a simple columnar. It is a transposition cipher that follow a simple rule for mixing up the character in plain text to form the ciphertext. So there are 3-step algorithm for a simple columnar. The message is written out in the rows of fixed length first. Whatever your plain text message is written in the row of fixed length, then read out again column by column according to given order. According to order, write ciphertext. So we are going to see the sum on this. So Convert plaintext welcome home in ciphertext using simple columnar with the key zebra. So in simple columnar transposition, plaintext is given with the key and the order, column order. Here column order is key is what? Zebra. So ZEBRAS. There are 6 characters in key. So we are going to draw the 6 columns. See, in solution 6 columns are written down. 1, 2, 3, 4, 5, 6. So in 6 columns we are going to write the plaintext row by row. So WELCOMEHOME. So this is what the first step. Write your message in 6 fixed length column, that is 6. We decide is 6 from the key zebras. Then write in the row order, and then in next step we are going to read all these character column by column by order 6, 2, 3, 2, 4, 1, 5. So in 6 column there is a M. So first character of the ciphertext will be M. Then 2. So in second column there is a then 3. After 6 there is a 3. So in third column there is a LO. Then 2 EH. Then 4 CM. Then 1 WE. Then 5 OE. So we are also going to practice this technique in also our live session. Thank you.